Hello students. This part of the notes, you don't have to write this part because I just wanted to start out with an introduction to what we call perfect square trinomials. And you don't have to write this part. If you want, you can write this on a sheet of paper, and then I'm going to switch over to the notes PDF that you have. So a perfect square trinomial, and I'm going to type this part. That is huge. So a perfect square trinomial is formed when we have a binomial, which remember has the two terms. So if we have a binomial that's squared. So if we have something like x plus 3 and that whole thing is squared. So what that means is this means x plus 3 times x plus 3. So it's formed when you have a binomial that's multiplied times itself and you multiply that out. And I could do my box method and all that. But if I multiply this out, it's going to be x squared plus 6x plus 9. So this right here is what we call a perfect square trinomial. And if we were to factor this perfect square trinomial, we would get x plus 3 times x plus 3, because we'd be going, backwards. And then we would write that as x plus 3 squared. Other examples of perfect square trinomials, x squared plus 12x plus 36 is a perfect square trinomial. And when you factor that, you get x plus 6 squared times itself. And what I want you to notice in these perfect square trinomials is this. If you look at the x term, if you look at the x term in each one of them, and you look at the constant term in each one of them, if you divide the x term by 2 and then square that number, you get the constant term. Let me show you what I'm talking about. So if I took that 12 and I divided that by 2, I would get 6. And then if I square that 6, I get that 36. Okay? Same thing over here. If I take the 6 and divide by 2, I get 3. And then 3 squared equals the 9 right there. It's always that way in every perfect square trinomial. Let's see another example. Let's see, x squared plus 14x. You could probably guess what goes here. Divide the 14 by 2 and then square it and you get 49. That is also a perfect square trinomial, and that would be x plus 7 squared. Let's see, what would be another example? Let's do one more. X squared plus, even numbers are better here because to divide by 2 and then square is going to be a mess if it's not an even number. Let's say I had x squared plus 20x, and I wanted to know what goes here for a perfect square trinomial. Well, take the 20, divide it by 2, and then square that number. So plus 100. That would be a perfect square trinomial. And if we wanted to factor this, it would be x plus 10. It's that number that I got when I divided this by 2. So it would be that squared. So that was just kind of an introduction. I wanted to show you these are perfect square trinomials. And what we're going to be doing is called completing the square, which is what I just did with the 100. But I want to take it just a little bit slower. So I want to go over to the notes. All right, so here's our notes for today. Let me see, how big do I want to make this today? What does it mean to complete the square? What you're going to be doing, and I'm going to write this today, you're going to be adding a number, which is what we did with the 100 and with the 49. You're going to be adding a number to an expression. That will allow you to and we're going to just say to factor a quadratic. And just as a reminder again, a quadratic is just an expression or an equation that has an x squared term. This is a quadratic because it is to the second power. So any expression where the highest degree term is x squared, in other words, it doesn't have an x cubed, it doesn't have an x to the fourth or whatever, the highest degree is x squared, that's called a quadratic. Okay, let's give an example of completing the square on a square. So, so if I put x plus 6 up here, remember this is our box method too, and x plus 6 here, this is x plus 6 squared. So if we put our products in the boxes, then we could write, and we did this one actually on that previous page. So x times x is x squared. This is 6x. This is also 6x, and this is 36. And so this is that 12x that we would look at divided by 2, and then this is that number squared. So my perfect square trinomial would end up being x squared plus 12x plus 36. All right, so then that middle term, that x term, which is what we look at first, divide it by 2 and then square it, and you get that 36. All right, what if we had something like, let's say we had x squared plus 6x plus what? We don't know, we need to know what. Well, if we know that it's going to be a 3 right here, right? And I'm going to put this on this square, but it's not really necessary for us because we've already been through this. We know it's going to be a 3, and then the 3 times the 3 is the 9, so that's what goes there. And all of these other ones should match up. Of course, these two add together to get the 6. That's just a kind of a longer, drawn-out way to do what we just did on the previous page. So if we have, sometimes what we'll have is something like on one side of the equation, we might have x squared plus 10x. Okay, and then we've got, on this side of the equation, we've got something else. We need to complete the square, the perfect square trinomial on this side to be able to solve the equation, to be able to get rid of the x squared. And so that's kind of what this part of this lesson is about. Let's move on down, and let's see, how do I want to, let me make this a little bit smaller because we can't see the whole thing. Okay, so steps for completing the square. The reason we complete the square is to solve a quadratic equation. This is just another way to solve it. It's another way to factor it. We've worked on factoring by splitting the middle term. We have worked on factoring by just looking for the factor pair that adds up to the middle term. This is called completing the square, and this is just another way to factor our quadratics with the x squared terms. So let's look at an example. So let's say we have x squared plus 30x, and we need to complete the square in order to be able to factor. It would be an equation, but we're just going to do this part first. We're going to do the left side of the equals first. What is your coefficient of your x term? And when they're talking about the x term, they're talking about the middle, or this term right here that goes with the x, not the middle term in this case. So the coefficient of the x term is 30. Okay, next step says take the number from step 1 and divide it by 2 and then square that. Okay, so 15 squared is 225. And so that's the number I'm looking for, 225. And we did this on the previous page again. This is just a little bit longer way to look at it. Add the number from step 2 to your original expression. So my original expression was x squared plus 30x plus the 225. So I'm going to add this right here, plus 225. Okay, then I can factor it. Well, I know that from my previous page that what I'm going to do is I'm going to be taking the square root of this, which is up here. So all I have to do is divide the 30 divided by 2. So the 30 divided by 2 is 15. That's going to be that number part of my binomial. So it's going to be x plus 15 squared is that simplified. Now, this part doesn't really serve a purpose without there being an equation. We're going to look at equations on the next section. But let's try that part one more time with a different set of numbers. So let's say you have x squared minus 6x instead of plus 6x. So what is the coefficient of the x term? It's negative 6 this time. Okay, so take -6, divide it by 2, and then whatever you get, square that. -6 divided by -2 is -3. -3 times -3 is 9. So it's still going to be a +9. So my expression is going to be x squared minus 6x plus 9. This is still a perfect square. But in this case, I take the -6 and divide it by 2. So it ends up being that, x minus 3 instead of x plus 3 in this one. So I would rewrite it like that. All right, so let's look at some actual real examples of this when we have an actual equation. So sometimes we get an equation, and the easiest way to solve it is to using completing the square. So let me just show you what that might look like. So let's say we have a problem like x squared plus 2x minus 24 equals 0. And we need to factor the left side of this. Well, let's see, -24. Is there a factor pair for -24 that will give me +2? There is. But the other thing I could do is, sometimes there isn't. Sometimes this is like a -20. And there's no factor pair that will give me 2. Well, in this case, there is, but we're going to pretend there isn't. So here's what we do. We move the number term, which is the constant right here, to the other side of the equation. Okay, so I'm going to add 24 to both sides. So then I have x squared plus 2x equals 24. Okay, and then the next thing I'm going to do, sorry, I can't get this thing to move. Okay, next thing I'm going to do is make sure my x squared term, I'm sorry, is a 1. So I can't have another number right here in front of the x. It has to be a 1. Okay, so if I don't have a 1 there, then I have to divide through. Like if this was a 2, I would have to divide all of these by 2. I don't have to do that here because it's already a 1. Okay, so now what I want to do is I want to, well, I'll just rewrite this. Okay, so it is a 1. So now I'm going to just work with the left side of the equation, and I'm going to complete the square. So let's see, working with the left side of the equation, I'm going to take that 2, I'm going to divide it by 2, and then I'm going to square it. Well, that equals 1. Okay, so then my left side of the equation, completing the square, is that. Okay. But if I add 1 on the left side to make this still equal, so if I'm going to add 1 to this, I got to add 1 to this also. So I have to do 24 plus 1, so that's 25. Okay? So instead of subtracting 1 from both sides, that would be, that wouldn't work. Then what I want to do, oh, let me rewrite that right here because this is the step. X squared plus 2x plus 1 equals 25. Okay, and then I factor my trinomial. So because I've just made a perfect square trinomial, all I need to do again is divide the 2 by 2. That equals 1, so that's going to be what goes in my parentheses, plus 1 equals 25. Okay, so if you remember from the previous lesson, the way we would solve this is we would take the square root of both sides, and then we would create a positive side. X plus 1 equals positive 5. And we would create a negative side. X plus 1 equals negative 5, because this right here would be x plus 1 equals plus or minus 5 right there. So this is the positive and the negative side, and then so x plus 1, or excuse me, x equals 4 or x equals -6. Well, of course, we kind of knew that up at the top anyway, but this was just an easy one to do. Okay. And it says check your solutions. I'm not going to do that. I'm not going to make you do that because I'm going to just tell you it's correct. Okay, another example. Let's do, okay, so this one is going to be get back, 2x squared minus 20x minus 22 equals 0. Okay, so instead of going through and doing like 22 times, or negative 22 times 2 and then finding a factor pair and splitting the middle term and all that, I think completing the square on this one is actually going to be easier than doing this the way we were doing it in a previous lesson. So let's see. I'm going to add 22 to both sides. So I can get this part by itself so I can do the completing the square. So let's see, that's going to be 2x squared minus 20x equals 22. Okay, now it says make sure your coefficient on your x term is a 1. Well, this is a 2. So what I have to do is I have to divide everything by 2 to make that x squared term a 1. All right, so this cancels. That's going to be x squared. This is going to be minus 10x because 20 divided by 2 is 10 equals 22 divided by 2 is 11. So now I'm only working with this side, I keep doing the box highlighter, this right here, and I'm going to leave the 11 alone for a second. What I need to do is complete the square on the left side. So let's do that. X squared minus 10x, just rewrite that. Okay, take your negative 10, divide it by 2, and then square this number. That's 25. So now I'm going to add 25, let's do a different color, 25 to this side. Well, if I add 25 here, I have to add 25 here also, equals 11 plus 25. So I added 25 to both sides. The reason I did that is because on the left side, I want to get a binomial that I can square so then I can finish solving this thing. Okay, so that means, okay, I did that. X squared plus 10x plus 25 equals, that's going to be 36. So on the left side, still working with just the left side really, we're going to divide that 10 by 2 again. So we're really just looking at this right here. We're going to divide that by 2. Wait, did that start out plus 10? No, it was, I'm sorry, it's minus 10. This is minus right here. Negative 10 divided by negative 2 is negative 5. So in my parentheses, I have x minus 5 squared equals 36. Okay, so then I can take the square root of both sides and take this out from under the radical. X minus 5 equals plus or minus 6. Okay, so this is where I create my two equations. Positive side, x minus 5 equals positive 6. So that's the positive side. Negative side is x minus 5 equals negative 6. Solve for x. I'm going to add 5 on both sides. X equals 11. And on this side, x equals negative 1. Sometimes we don't get so lucky. Sometimes we end up with radicals on these. And if that happens, we just write them in simplest radical form. This one's not that way. Maybe we'll have some of those on the classwork. Okay, so that is completing the square. So it really has to do with that middle term, dividing by 2, taking the, and then squaring it. Okay, so the other thing that we want to talk about is using the quadratic formula. And you might have seen this before. You might not have, but we're going to work with quadratic formula. And you do not need to memorize quadratic formula. It's right here. It's right here. And it can always be in front of you, except maybe on your exam. You might want to remember it. Oh, you don't have an exam if you're in Math 2. Math 3, you will. Okay, so let's see. Let's do an example. X squared plus 3x plus 2 equals 0. So as long as you have 0 over here, you can use quadratic formula. If you don't have 0 over here, then you make it so that there is a 0 over here. So if there was a 4 over here, then I would subtract 4 from both sides and make sure there was a 0 on that side. Okay. Rewrite your equation. It's already in standard form, but we'll rewrite it. X squared plus 3x plus 2 equals 0. So what they mean is if it said x squared plus 3x, don't write this, plus 2 equals 4. You would need to rewrite it with the 0 on the right side. We don't have that situation. This one might have said x squared plus 3x equals negative 2. So then you would have to add a 2 to both sides. That's what they're talking about. And so that's what we would have done there. Now, we locate our A, B, and C. Okay, different colors. A is the coefficient of the x squared. B is the coefficient of the x. And C is the constant term. Okay, so A, B, C. So let's locate those. Let's figure out what they are. A is 1 because it doesn't have anything in front of it. A is 1. B is 3. And C is 2. Okay, then what we do is we plug them in to the quadratic formula. Here's quadratic formula. So we have to plug these numbers in. Let me get a different color. X equals, and that's going to be a big fraction. Okay, this is the opposite of B. So the opposite of B is negative 3 plus or minus. There's another situation where the plus or minus comes in. I had to fix my line there. Okay, plus or minus the square root of B squared. So 3 squared, I'm going to go ahead and write that, is 9. 3 squared is 9. Minus 4 times A times C. Okay, so 4 times A times C. 1 times 2. So that's going to be 2. Okay. You could go ahead and rewrite that too. Let's go ahead and rewrite that. That's going to be 8. 9 minus 8. That's easy. So it's 4 times A times C. 9 minus 4 times A times C. 4 times 1 times 2. So that's 8. And then all of that over 2 times A. So that's 2. So then we just do the math here. I have to use my fingers every time I move this thing down because my tablet thing won't work. My stylus won't work. All right, and we're running out of time. All right, so x equals negative 3 plus or minus the square root of 1 divided by 2. Then we can split it into 2 different sides by taking the 1 out from under the radical. So it's going to be negative 3 plus square root of 1. And the square root of 1 is 1 over 2. And then the other side is going to be negative 3 minus 1 over 2. All right, what's negative 3 plus 1? Negative 2. Divided by 2, negative 1. So that's our answer. That's one of the answers. The other answer is negative 3 minus 1 is negative 4. Divided by 2 is negative 2. So there's 2 answers, negative 1 and negative 2. Instead of doing another example right now, what I want to do is I want to take you over to Desmos and show you what you could have done here. Now, this is not always the case. You can go over to Desmos, though, and actually check your work. So let's, what you want to do is type in desmos.com, and then I'm going to bring this over here. So you can check your work. You really don't want to try to solve these because you could have an imaginary root, and you don't want to try to solve these if there's an imaginary root because it won't show it to you. Okay, so what we could do though is we can enter x squared plus 3x plus 2, and then look and see. We're going to zoom in here, look and see where it crosses the x-axis at negative 2 and negative 1. What was our answer? -2, and -1. So that means we did it correctly. I'm actually going to stop here. I'll spend more time on this on the classwork, but I'm at 25 minutes, so I don't want to keep y'all any longer. So let me know if you have any questions during the live lesson, and then move on to the classwork.